For the applying of loads, I will click at the center, and for that first of all I have to draw the point, because for example when I click at the center, you see here one area for the selected node, the center point is clicking. For the clicking of center point, I will go in the draw points. Here is the 0 0. Okay, now you can see the point have been drawn. I will deselect. Now if I go in the center and just click, here you can see one point selected. Now I will go in the assign load data point loads. Here I will assign the loads to the footing live load. For example, the axial load, that it will be downward gravity load in the -z direction. X is this direction, y is this direction, z is upward direction. This is -z means downward load. So here I will apply 150 kilonewton. Mx will be 33 kilonewton meter, My will be 50 kilonewton meter. And here is a you have to must provide this x dimension and y dimension for point loads. What is that? That will be size of your column. So here your size of column is 300 millimeter. So I will put here 300, 300. And here is your three options: add to existing load, replace existing load, delete existing load. If I want to delete the existing load, I will click here and come here, delete, click, select the delete existing load and click OK. Software delete all the loads from this point. Second is replace existing point. Matlab if any load is previously present, then software replace the loads with this. Add to existing loads, for example, if I have applied the loads and I want to increase, I will just come here, put the loads and add. Software automatically add into these loads. So here I will select replace, because even this both options, first time this first option work in the same way, because no loads is present previously. So okay, here you can see the loads have been applied. For seeing the values, you click ready. In this you can see here 150 downward, that will be single arrow, and double arrow show the movements: 33 kilonewton meter, 50 kilonewton meter. Okay, now I will define the load patterns. Define load pattern, that is the default dead one live one, that is always one self weight multiplier, means software automatically take the self weight of the footing. Okay, live load, that I have applied. Okay, now I will define the load combination. For load combination, I will click at default design combination and click the ultimate. Okay, software created the two ultimate conditions: 1.4 dead and 1.2 dead plus 1.6 live. Okay, that is according to ACI. And one combination I will create for the service load. Dead plus live. Here I will put dead 1 live 1. Okay, that will be service normal condition, because I will check two checks against service loads and one check against ultimate conditions. Two check, that will be bearing capacity and allowable settlement, I will check against the service loads, and one check punching shear, that will be against uh, ultimate conditions. Now I have defined all the things before. First of all I will save the model. For saving the model, ISO dated footing design. Okay, I will click save. Here is the model name. Now I will define the stirrups, means design stirrups. So I will go edit, add design strips. Why we need the design strips? Basically software calculate uh, the forces for the strip based method on these lines. This is for X. Now I will go for the Y direction, edit, add design strips in the Y direction, B. Okay, so here software created the design strips up till here. I have to move at the end. For that I will just click the reshape command and click here. From here I will take at the end, Similarly, I will take this uh, stirrup and move it to end, so that software calculate the moments at the whole footing slab. Okay, now I have defined the grid system, load combinations, loads, all the things. Now I will click run analysis and design. Here, after running the analysis, default displacements are against that. So here are the displacement. Downward displacement is maximum minus 88 millimeter. I will go in the display, show deform shape against service load combination, combo dot plus live, apply. Now I see what is the maximum deformation. Maximum deformation is minus 6.9 downward. So downward maximum deformation allowable is 25 millimeter. So it's our deformation check is okay. Now I will go in the display, show reaction forces. I will click again in the uh, service load combination and click soil pressure, apply. Okay, now I will come check what is the maximum minimum, and the bigger value is 55 kilonewton per meter square. Our allowable bearing pressure is 200 kPa, mean kilopascal. So our loading is under control, means the pressure from the above loads is less than the allowable, so it means okay, this is the pressure generated by the loads. Our allowable is 200 kPa, it means it's okay. Now I will check third check, that will be punching shear design check. Here, that is also okay, that is less than 1. For details of punching shear check, you will just right click at the punching shear value. Here the software gives you detailed design, what is the unbalanced moments, what is the maximum shear capacity of the footing, what is the applied shear stress. So here is the ratio punching shear, so that is a less than 1, it means our check is okay. Okay, punching shear check is okay. Now we'll see the movement, what are the movements, what are the shear in the stirrups. Display, show strip forces, that is a very good thing. Now we will check all the things against the ultimate condition, that is a 1.2 that plus 1.6 live, apply. In this direction, layer A, what is the maximum movement, that is a 80 kilonewton meter, and for the y direction, here that is a 1.16 kilonewton meter, that is his side 50, so maximum moment is 80 kilonewton meter. So I will click go close. Okay, now I will run the detailing. Here the detailing, that is basically grid spacing 5 meter 3 meter. Here is a footing, so here I will click footing layout plan, that is a footing table. Here is a footing table, that is a footing F1, one number, its x dimension, y dimension 2.5 meter, 2.5 meter, thickness of the footing, that is a 0.3 meter. How many bars are required, you can see here. So just it's giving the total number of bars, that is a 7 number 14 in the in this direction, matlab x direction, and in the y direction that will be 6 number 12 bars. Here is the bill of quantity. Okay, so now for the detail reinforcement, I will go in the display, show slab design. Okay, when I will click, here is a two options, strip base or finite element method. First of all, I will click strip base because I have defined the strips here, and I will see the reinforcement in the layer A, apply. So when I move the cursor above the strip, you can see top and bottom reinforcement. Here is a, at bottom more reinforcement requirement, at top negligible. Similarly, if I impose the minimum criteria, means minimum reinforcement criteria, apply. So you can see The minimum reinforcement criteria will govern this design. Okay, similarly for layer B you can see in this y direction. So now how many reinforcement is required at what spacing you can also check here. Typical. So now I am selecting for example number 12 bar at this spacing, for example 250 millimeter, 250 millimeter at top and bottom. Apply. So it means higher reinforcement is required. I am reducing the distance, for example 150 millimeter, 150 millimeter. Apply. You can see 150 millimeter is okay in both the directions. So if I make it 200, will it be okay? Let's see. Apply. So it means number 12 at the 200 spacing in both directions is also satisfied. Same you can also check for the by the second method, that will be finite element method. Apply. You can see the reinforcement, for example 467 millimeter square per meter here in the bottom x direction. You can see all the results. Similarly y direction, top two direction 2, that is the local axis. For the slabs local axis, 1 is x direction, 2 is the y direction, and 3 is in the z direction. Similarly for bottom reinforcement. Okay, so again you can also typical justify that will it be okay 200 millimeter. Apply. Okay, so you can see in the FEM method he is saying some more reinforcement is also required, just like to 35 or 36 millimeter scale. So I am just reducing it to 175, 175. So only I am checking the bottom, so I need to just revise 175. So you can check for the top. Apply. So it means some more reinforcement is also required, so I am reducing it to 150. Apply. Now it's justified. So for bottom in this in the one direction, that is also so satisfied at this. So let's see for the top. Okay, for top that will be I think 200 is also justified. Apply. Apply. So 200 for the top spacing, and for bottom spacing that is will be 150 millimeter. So that's how you see the reinforcement design in the CSI SAFE software. So now we have seen all the things: how to draw the isolated footing, how to check the allowable bearing pressure, allowable settlement, and punching shear design. Then we have seen the design reinforcement, how to justify, and how to detail the reinforcement. For more precise detailing, you can also set the preferences for the detailing. For example, what bars you need for the detailing. So all these things you can justify in this isolated footing detailing option. So that's all for isolated footing design. Thank you.